this lesson, you'll learn the definitions of important terms and the basics of Linux network troubleshooting. Since the usefulness of a Linux server fully depends on network connectivity, it is important to know some basics of how to troubleshoot network issues from the Linux point of view. This lesson involves more than one host, so I set up two different Linux servers, one running Red Hat Enterprise Linux 8 and the other running Red Hat Enterprise Linux 7.6. Both systems are patched up and updated. Today, we're going to be talking about Linux networking protocols such as TCP/IP or UDP, network ports. Let us look a little closer at some of the acronyms and nomenclature, so that you're clear on what we're going to be talking about further on in the lesson. Here are some important acronyms we're going to learn today. IP, IP address, hostname, network, localnet, localhost, network port, protocol, network route, Linux gateway, DNS, network interface, network cable, routers, nethops, traceroute, ping, and telnet. This is what they mean. IP, Internet Protocol. IP address, a numeric identification address, equivalent to a phone number. Host name, the given name of a machine host. Network, a group of computer and peripherals that can communicate with one another through a network link. Localnet, a locally connected network local to the system and not across the internet. Localhost, it means the host itself. It has an IP address of 127.0.0.1. Network port, a network port is attached to a network IP address. It is a door, if you will, to a Linux system service that is listening to requests in that particular port number from the outside across the network or the internet. C/etc/services. Protocol. It is found at the transport layer, fourth layer, of the Open Systems Interconnection Model, OSI model. Example, TCP/IP, UDP, ICMP, etc. Network route. It is a path through the network. Linux gateway. The door to the outside world from a computer's point of view. All network traffic gets routed through and from the gateway. DNS. Domain Name Service. It translates IP into a fully qualified domain name or a fully qualified domain name into an IP address. The Internet phone book. Network interface, most commonly referred to as a NIC card. It stands for Network Interface Card, a piece of digital computer hardware that allows the computer to communicate with a computer network. Network cable. This is the physical layer, first layer of the OSI model. Routers, used to route traffic between networks. At home, it usually routes between the local home and the internet. Routers, used to route traffic between networks. At home, it usually routes between the local home network and the internet. Nethops, the number of hosts a packet must travel before it reaches its destination. Traceroute, it is a Linux network utility that traces the route between network points. It will show how many network hops are between the server and the target IP address. Ping, a common network utility that measures the reachability of network hosts. Telnet, it is a Linux network terminal that listens for requests at port 23 of TCP/IP. Basics of troubleshooting. To be a good troubleshooter, you have to be good at assessing and asserting situations. To find a solution for any problem, one must first understand clearly what is the problem, so as not to spend time looking for a problem where it isn't. To understand exactly what the problem is before you start troubleshooting is key to point your efforts in the right direction. Being good at solving problems outside of your job is a good start. Whenever doing troubleshooting professionally, being able to deliver results and solutions consistently is key to reliability. As a Linux system administrator, you must be reliable. Reliable to yourself, to the company you work for, your boss, your company peers and coworkers, and the systems you manage. Whether you're an innate troubleshooter or not, you can always learn and improve upon your own knowledge one day at a time. Read up and watch videos on the subject. Getting into the right mindset will help you stay focused and to see more options and different paths. You'll slowly but surely evolve into a better troubleshooter, no matter which level you currently are. It is very important to understand whatever it is that you are going to troubleshoot beforehand. You must know what it is and what it does, and how it was supposed to be behaving or working. If you don't know what it is that you're about to troubleshoot, this is then the perfect time to do your research. Stop and go research and learn about it and understand what's expected of it. While you're at it, you might want to take a quick look at the FAQ if one is available. Someone might have already been through the same issue and documented the problem and resolution. It is all about information and knowing when and where to find it. The first step in troubleshooting network in Linux is to attempt to ping your localhost, and then some host on the internet. You can do this by issuing this command: ping localhost. Or you can also ping the localhost IP address. You should see a result, and there should not be any timeouts or any other issues with the ping command response. You can then ping a host on the internet. For an example, let's ping Google. You should see a similar response with a little bit higher network latency. To check your host network configuration and see your local IP address, use ifconfig. ifconfig is showing that the interface connecting to the network and to the internet is ENP0S3, and it has a local network address of 192.168.1.170. Next, you should check the host to see if it is using the proper DNS server for its network name resolution by looking at this file, /etc/resolve.conf. All the host NIC cards will have its configuration files located at this directory, /etc/sysconfig/network-scripts. And there's the configuration file for the current network interface. It looks like this. If you wish to see the current configuration of a certain network interface, you can use the IP netconf dev device name on Red Hat 7.6. We just looked at the interface just to make sure. And the same thing would be on the Red Hat 8. For this setup, we dedicated 2 Linux servers: a Red Hat Enterprise Linux version 7.6 with an IP of 192.168.1.169 and hostname RHEL76, and also a Red Hat Enterprise Linux version 8 with an IP of 192.168.1.170 and hostname RHEL8. We can now test network connectivity between those 2 network hosts. At the 7.6 version host, we type and at the Red Hat 8, we type and we can interrupt that now. We can experiment and attempt to telnet onto the port 22 on the Red Hat 7.6 to see if his service is listening on that port. And it shows the SSH daemon is answering. This way, we confirm that we can reach the host and that we can reach the port 22 where the SSH is listening for login requests. Another great tool to use in network troubleshooting is TCP dump. Capturing the screen output of TCP dump into a file for human eyes review should look like this. And indeed, we captured 26 packets. Capturing the network packets into a PCAP file for use with network analyzers will go like this. Use command line parameter -w. We're still pinging back from the Red Hat 7.6. So by now we should have some packets. And we captured 24 packets. Now let's look into the traceroute command. And let us traceroute the Red Hat 8. And the traceroute command shows you that there's one hop between your hosts, one network hop. Now let us ping it a little differently with a short time to live and an interval of 0.3 of a second with a weight of 0. And let us send 10 packets this way. At the same time, let us go to Red Hat 8 and attempt to capture that. And now let's issue the ping command. You should be able to see both sides. As an exercise and out of curiosity, let us keep the TCP dump command running while we go on a different terminal tab on the Red Hat 8 and sabotage the network by routing the traffic coming from the host Red Hat 7.6 to a black hole. And we can do that this way. First, we go on the Red Hat 7.6 and we start pinging the Red Hat 8 host. Once we do that, we leave it pinging from the Red Hat 7.6 to the Red Hat 8. Now we issue the command to drop the network connectivity by routing it to a black hole. Sudo IP route add black hole to 192.168.1.169. When we issue this, it's gonna block the communications. Let's see. Wait for it. And the connection is dropped. Watch the messages on the Red Hat 7.6. It says destination host is unreachable. Now that we're satisfied with our task, it's a good idea to remove that black hole by issuing this command. We just delete that route. Like this. And the connection should be instantly reestablished. As you can see, Red Hat 7.6 is already getting responses. Today, we learned about becoming or being a troubleshooter and how to improve on a daily basis. Research is your friend. You should do it often, especially because it may give you an edge and allow you to see more than one troubleshooting route to pursue. We also learned about some important acronyms, the location of important system-wide network configuration files, several different tools that you can use to troubleshoot network issues. Read up on their man pages and learn every resource the network utility tool can provide you with. This will help you become more fluent at it. See you next time.